Hello everyone, myself Himanshu Dhupia. I welcome you all at the Universal Group of Institutions. Today, our main topic of discussions would be magnets, magnetism, magnetic field and geodynamo. These all phenomena helps to understand about our universes. Along with the geodynamo, we will have a brief overview of paleomagnetism and geomagnetic reversal also. Alright, so all these these are the complex topics. So we will try to make it very easy, okay, and if you have any issues, we can you can just write in the comment box and we will sort it out. So till then, stay tuned for that. Make sure you subscribe the channel, make the notification bell on so that you can get the videos first. Alright, so students, what is magnet? So magnet is a material that attracts or repels any similar kind of material in the surrounding. So this is suppose this is a magnet, and all these are the iron, iron fillings. So generally we know that iron is the magnetic material, but there are also other materials like nickel and cobalt. Those are also having the magnetic properties, but the most significant is iron. That's why we use refrigerator magnets and all. So that is the magnet. Either it will attract or it will repel the similar kind of materials. So this particular attraction or repulsion is due to why this attraction is going on. If you are having one magnet like this, and if this is the iron, if I am putting this magnet nearby, it will try to come near it. So why this is happening? This is happening due to magnetic field. Okay, magnetic field means, suppose this is a bar magnet, and the magnetic field means the surrounding of this particular magnet is called magnetic field, but where it is exerting the force, it is forcing towards it. Okay, so basically in the diagram also you can understand that, see, this magnet is there, and these particular arrows are the magnetic field. This diagram is illustrating you how the magnetic fields are generated. Okay, fine. Now what will be the strength of magnetic field? So basically simple is that if this is a magnet and if this is a iron, so more closer it will be, more the magnetic field will be stronger. You have to remember that. Okay, if this is the case, the strength will be more. If we are moving it apart, pulling it apart, then the magnetic field will be decreasing. Okay, simple funda. Okay, fine. Then types of magnet. So there are different types of magnet, students, based on the nature. Nature means like permanent magnets, temporary magnets and electromagnets. So these all are the types of magnets in our environment. So electromagnet, or we can say solenoid also. These magnets, if we talk about each one of them, if I talk about the permanent magnet, a permanent magnet is an object made from a material that is magnetized. Remember, what is magnetized means? That is having full property of magnet. That is called magnetization. Okay, and how it creates? So basically it is, obviously we will get magnets from the earth itself, and these particular permanent magnets will have their own magnetic field. We don't need to put external force to have the magnetic fields like we will do in the electromagnet. Remember that thing. So these permanent magnets will have their own magnetic field. An everyday example is a refrigerator magnet used to hold notes on a refrigerator door. An example being this. In every home we have the refrigerator, and in all these, see the photo, like the person is a very vegetarian, seems that it is having lot of magnetic refrigerator magnets. We simply put on the magnet, we simply put on the refrigerator door, and it will be it will be connected to that. So these are called permanent magnets. Simple. Second is that there are types of permanent magnets also. So first of all, we are talking about types of magnets: permanent, temporary, and this electromagnet. Then there are 5 types of permanent magnets also. Example being alnico. So this is our alnico. Second is samarium cobalt. Third is ferrite. Fourth is flexible rubber, and the strongest permanent magnet is neodymium magnet. So these are our neodymium magnets. You have to remember, okay, in examination question can be asked students that which of the following are the strongest permanent magnets? Answer would be neodymium magnets. Okay. Now let's talk about temporary magnets. So temporary magnets are made up of soft metals that retain their magnetism only when they are near a permanent magnetic field or an electrical current. So these are the temporary magnets. See, as you insert the photo, this is a permanent magnet. PM I am writing permanent magnet, and these iron clippings are simply iron. They are not having magnetic property, but the moment you will they will find a magnet in the proximity, they will behave like a temporary magnet. Can you see in the photo itself, right? See this. So this particular clipping was attached to magnet, but now this is also behaving like a magnet and it is also attracting this second one. Now this has become magnet, so it is attracting the third one, fourth one, fifth one and sixth one, like it will keep on going. Now after some time these clippings won't have that much magnetic power as the first one, because you know the rule that the more we move away from the magnet, the magnetic field decreases. Okay, fine. So this is the temporary magnet. Now second is the temporary magnet by currents. So this is our temporary magnet. So with the help of electrical current we are making a temporary magnet. So this is a cell in front of you. This is a cell, and when we are putting copper wire along they are rolling the copper wire on a nail, on an iron nail, and we are giving charge to that particular nail, so it will behave like a temporary magnet. See these clippings, these are getting attracted to this particular magnet. Okay, so these are our temporary magnets. Third one is electromagnet. So electromagnet means whatever we did here, this is called electromagnet only. Okay, so temporary magnets are made out of soft metal that retain their magnetization only when they are near a permanent magnetic field or a electric current. So basically this is called electromagnet, temporary magnet. So temporary magnet and electromagnet is not that much different, but see the difference is this only. This is the difference between these two, that some of temporary magnets, mean these iron clippings are temporary magnets. This nail is also temporary magnet, but this nail has become magnetized due to the electricity. That's why it is called electromagnet. Okay, fine. Now if we talk about the shapes of magnets, so there are different shapes. The first is bar magnet. This is called bar magnet. This is called spherical magnets, or this is called U-shaped magnet, and this is called spherical magnets. So these are the shapes of the magnets. Okay. Now if we talk about the properties of magnets, so there are many properties of magnets. There are these are the properties, so we will talk about each property in detail. Okay, so the first property is, if you dip a magnet into iron fillings, and you will see that the fillings stick to the ends of the magnet. Can you see this? This is a magnet, and these are the iron fillings. These are the iron fillings. So when you are putting this particular magnet into a bowl of fillings of iron fillings, so notice one thing. Some of the iron fillings are sticking to the left, and some of them are sticking to the right. Okay, some are left, some are right. Why? Because of the poles. So second characteristic of this particular, second property of magnet is the poles itself. So before going that, I want to tell you that this happens due to attraction is strongest the pole of the. So if in examination questions is being asked that where is the most strongest point of magnet, the answer would be poles, and these are north and south pole. Now we are going to the we are slowly moving toward our Earth's geomagnetism also. Okay, fine. Now second property of magnet is that pairs of magnetic poles always exist. Suppose that this is a bar magnet. Which magnet is this? Bar magnet. Okay, now if I break this particular, if I crack this magnet, so you will think north will become north and south will become south. No, immediately north and south will be formed. So in a magnet, never ever only one poles can be possible. That is not a magnet. Okay, remember. So if I break open this particular bar magnet, immediately there will be N and S like this. Immediately there will be two poles. Always poles will be exist together. Okay. This particular region is called neutral zone. Fine. Third is, whenever a magnet is suspended freely in mid-air, it always aligns with the Earth's magnetic field. Very interesting thing. Let me show you by the example itself. That suppose that I'm having this particular, this particular rope, okay, and if I'm putting, suppose that this particular, this is a magnet. So if I will suspend this magnet, it will automatically align toward the magnetic field of the Earth. So if suppose this is a magnet, then what will happen? Wherever it will point into the north, it will be called as the north poles basically. So this is how the compass also works. Okay, remember that thing. So the end pointing toward the geographic north pole is known as north pole, and the end pointing towards the geographic south pole is known as south pole. This is how we recognize the poles. Okay. Fine. Fourth property of magnet is, this particular magnet opposite poles attract. Okay, opposite poles attract means if this is south, this is north, so south will be attracting to north, not north. Remember that. In the illustration also it's clearly written here, clearly shown to you that when if there are two if there are two magnets, if this is the north, this is the south, they will attach to each other. If both are north, they will repel. Whatever you try, you can touch them, but you won't be able to. The moment you will have the loose hands, it will repel you. So north or south pole will repel each other. North north will attract each other. That is the property. Okay, perfect example is here in front of you. Now fifth is, the magnetic force between two magnets increases as the distance between them decreases. Means the magnetic force between the two magnets increases. As the distance will decrease, the magnetic force will also decrease. Okay, simple as that. Next property, before going to the next property of magnetism, I want to convey the message that admissions are open on the Universal Group of Institutions for 2025-2026 semester session. So we are offering the integrated course for PUC, Commerce and Arts. Along with the PUC, we are preparing students for the CLAT, CSET, CUET and CA examination. In degree BCom, we are offering CA along with the IAS, IPS and KAS. In BSc and BA, we are offering IAS, IPS and KAS. Okay, and we are beginning a new course, MA Political Science also, that will help you in preparation for the further studies and higher studies. So admissions are open. You can enroll now. You can contact on this number, or you can visit our website universalinstitutions.com, or you can just visit our headquarter also, that is in the Ramohalli, Bangalore. Okay, so go check that out. Fine. Next is magnetism. So magnetism is the force of attraction or repulsion between objects due to the magnetic field. So basically students, this, can you see this? These are the iron fillings. So these are attracting or repulsing. Though two things are going on, some of the iron fillings are getting attached and some of them are getting repulsive. This particular force is called magnetism. Simple. And what about magnetic field? Magnetic field is an area, like this is the magnet. So this is the magnetic field of this particular magnet. So magnetic field, an area around a magnet, moving electric charge or current carrying conductor where a magnetic force can be detected. So this is called our magnetic field. So this particular field is also called as vector field also. Okay, what is this vector field? Why it is called vector field? Simple reason is that a vector field means when the magnetic field has two important properties. Magnitude means, so this particular component or element of magnetic field will tell you how strong the magnetic field is at the particular point. Suppose that I want to calculate the magnetic field of this particular point, then magnitude will tell you. Direction means these are the directions, okay, these are the directions. Are you getting the point? These are the direction. So this particular thing will show the magnetic force is acting at that particular point. So these are called, that's why this particular field is called vector field. Okay, you will remember that, remember, okay, yeah. Next we will talk about the Earth's magnetic field, okay. Earth's magnetic field, the geomagnetic field is the magnetic field that extends from Earth's interior out into space, where it interacts with the solar wind, a stream of charged particles emanating from the sun. Don't worry, I will tell you. So as you can see, this is our Earth, okay. We have the North Pole and South Pole also, okay. So there are two types of poles. There, one is magnetic North Pole, first is and second is geographic North Pole. Remember, both the poles will be at the same side only the difference is the angle, 11.5 degrees. So they will differ, geographic North Pole and South magnetic pole, they will differ by only 11.5 degrees. So that degree you have to remember, okay. Now why I told you about these magnets and magnetism and magnetic field? To show you that our Earth is also behaving like a magnet only, okay. So our Earth is like a magnet and it is having the electrical field. So these are the electrical field, magnetic field. So Earth's magnetic field is called geomagnetic field. Remember, this is called geomagnetic field. Understood? So this is, our Earth is like a magnet and the area it is surrounding, the force it is exerting in the surrounding area is called geomagnetic field, okay. Now the thing is that when our magnetic field is expanding basically, so it will interact with the solar winds that are coming from the sun also. So these winds are called solar winds because these winds are coming from the sun and it is impacting our Earth's atmosphere, okay. So our Earth's magnetic field will, see this, our Earth's magnetic field will confront the solar winds that is coming from the sun, and this is what our ionosphere, magnetosphere is. You know aurora borealis, aurora australis, remember? Aurora borealis and aurora australis. Aurora borealis and aurora australis, these are formed due to this interaction only, okay. Now you understand, in examination question was asked that aurora borealis are present in which layer of atmosphere? Answer was thermosphere. In thermosphere also, ionosphere is a secondary layer where it is present, where it is created basically, okay. Now how exactly these magnetic fields are generated? I told you that these are generated, Earth is generating magnetic field because of the magnetic property of Earth, that is the overview. But if I talk about the exact more depth, because we are reading the geography for UPSC especially in KAS means, so this particular magnetic field is generated by the electric current due to the motion of convection. So, simple is that, sir, you might ask me, sir, you told me that magnet is having magnetic field, I understand, but how our Earth is behaving like a magnet? That is the main issue. So this particular point is letting you understand that how our Earth is behaving like the magnet, okay, how our Earth is behaving like a magnet and it is having the magnetic field. So read the definition. The magnetic field is generated by the electric currents due to the motion of convection current of a mixture of molten iron and nickel in Earth's outer core, okay. So basically what is happening, beta, this is the outer core and this particular area of the Earth is containing Nephe. Nephe means nickel and ferrous, and this nickel and ferrous are both in the liquid form, okay, and these are the magnetic materials along with the iron also. So because of the core, because of the Nephe, because of this Nephe, nickel and ferrous, that is rising to the Earth crust and it is rotating here. It is rotating here. These are called convection currents. So basically when our Earth is getting rotation, all this convection current will also rotate basically beneath the Earth's surface. So when that magma when that molten rocks are moving with the help of convection currents, it exerts a magnetic force that is called our geomagnetic field basically. Okay, so the process, the mechanism by which Earth's magnetic field is generated is called geodynamo. Do you understand now? Okay, so what I'm saying, that Earth's magnetic, all this mechanism is what called geodynamo. Okay, so geodynamo is that. So geodynamo refers to mechanism by which Earth's magnetic field is generated. This is the Earth, this is the real photo, this is the real basically illustration that how our Earth is having the magnetic field. Okay, how it is exerting to the outer space. Okay, now this geodynamo process occurs within the planet's liquid outer core. See, there are the cores. This is our Earth crust. Okay, this upper layer is our Earth crust. There are two types of Earth crust, continental crust and oceanic crust. So continental crust is made up of granite and oceanic crust is made up of basalt. This is the first crust. This is the first layer of atmosphere, layer of basically of our Earth interior. Then comes second is asthenosphere. Below asthenosphere we have the mantle. This is our mantle. Then comes our core. So there are two types of core. First is outer core and second is inner core. So inner core, this particular area, this is our inner core, that is solid. Then comes outer core. Outer core is liquid, from where the convection current starts. From here the convection current starts, then it goes to mantle. There are two types of mantle also, upper mantle and lower mantle. So upper mantle is asthenosphere, lower mantle is mesosphere. Okay, fine. Now I have covered this thing. Now the movement of this conductive material. What is conductive materials? Conductive materials means this Nephe, nickel and ferrous. These are the conductive materials driven by the convection current. These are called convection currents. These are influenced by the earth rotation. Why this is convection current is happening? Yes, due to the molten magma. What happens? The molten magma's density decreases as comparison to the left and right rocks. It will rise up, but also because of the earth rotation also it will rise. Earth rotation also it will rise. That will produce electric currents and in turn it will generate the geomagnetic field or Earth's magnetic field. Okay, remember? And this convection current theory was given by whom? Arthur Holmes in 1930s, because he was the first one to tell about these currents in the mantle, that this is how the magma moves beneath the earth's surface. Okay, who told? Remember the name, Arthur Holmes. And this particular convection current theory is the soul, is the basic of sea spreading theory that we will cover in the next lecture. Paleomagnetism, that we will cover in that what exactly sea spreading theory is. Okay, now so basically these currents are generated due to radioactive elements causing thermal difference in the mantle. That we will talk, don't worry. In convection current theory, sea floor spreading, all are connected with each other. For now, just understand this geodynamo, magnetic field is due to also this convection current theory. And this is how we at Universal Group of Institutions, we just deliver the lectures, the offline mode also. So IAS and KAS prelims and mains preparations are going on. So seats are limited. You can enroll in our offline classroom sessions at uccindia.org, or you can contact on these numbers, or you can just visit our headquarters present at Vijayanagar, Karnataka. Okay, now we will talk about this theory later. For now, just understand that rising limbs means these are the rising limbs where hotter, less dense material rises. Understood? Why this material is rising? Because there are three types of matter, right? Gas, solid and liquid. Now, if we compare liquid and solid, the density of liquid will be less and the density of solid will be more. Now, if these rocks are melting, what will happen? It will change into the semi-liquid form, means the density of that particular molten rocks will be less than the density of the nearby rocks. What will happen? It will rise. Remember, it will rise. Now when this limb is going up, it's okay. Now if some of the molten magma will come out, it will change into volcano. But not all the molten rocks will be coming out. You have to remember that. So what will happen? The molten rocks will be nearby the earth crust, and it will solidify, it will become dense, and if the density will be more, again it will sink down. So always remember, rising limb will be hotter, less dense material, that's why it is rising, and the falling limb means where cooler and dense material sinks. Remember. Now when the rising limbs will be there, what will happen? Plates will diverge. Don't you think, if this limb is going like this, this limb is going like this, don't you think the plates that is above it, it will also diverge? Okay, so formations of oceanic ridges will take place, means where the plates divergent plate boundary will be there, ocean ridges will be formed. I already told you that the biggest oceanic ridge in the world is mid-Atlantic oceanic ridges. And the falling limbs of mantle convection, what will happen? If the limbs are falling, don't you think it will carry the rocks also along with it? The plate boundary will also go down, the plates will also go down. Then the trenches will be formed. Remember, convergent boundary, this is convergent boundary, this is divergent boundary. Okay, the formation of trenches, Mariana Trench is the deepest trench in the world, like I have repeated 7 to 8 times now. Okay, you have to remember that. Fine. Paleomagnetism. What is paleomagnetism? So I will talk about paleomagnetism in detail in the later. So we will talk about paleomagnetism later in detail, but for now I will give you an overview that paleomagnetism is the study of the record of Earth's magnetic field. So basically this is our Earth, and our Earth's magnetic field's record is known as paleomagnetism. Now you might be wondering, why do we need the record of Earth magnetic field? Earth's magnetic field should be permanent, but it is not. Okay, remember that our Earth's magnetic field keeps on changing. That is what our paleomagnetism is, and that is the strong evidence of the plate tectonics theory also, continental drifts also, that we will cover in the later part. So the polarity of Earth's magnetic field and magnetic field reversals are the detectable by studying the rocks of different ages. That is called our paleomagnetism is. Okay, so basalt means basalt are the rocks they are formed from the underwater volcanic activity. Means suppose that this is our sea surface, and volcanoes are coming out. So the sea floor will be the rocks that made up the sea floor is called basaltic rocks. Okay, and the continental rock is granitic. So this basaltic rock will have low silica iron rich. Iron means iron, again the magnetic properties are very high. That makes up the most of ocean floors. Okay, so this basalt contains magnetic minerals like ferrous, cobalt and nickel. Okay, so now I think we are catching up that why in ocean floors we find the most evidence of the paleomagnetism. Okay, because as the rock is solidifying, don't you think if this rock is getting solidified, wherever the north pole and south will be there, the direction of the minerals will be at the north or south. Remember, now suppose that the magnetic reversal has happened, that north pole has come here and south pole has come here. So what will happen? The next time when the volcano eruption will happen, so the cobalt, earlier the direction will be this, later part the direction of rocks will be like that. Okay, this is called geomagnetic reversal. We have find out like this, that some of the rocks are pointing into the left and right direction, some are pointing into the right direction. How is it possible? See, both are same rocks, both are having same magnetic properties. It shows that our poles are also changing through the ages. You have to remember that. Okay, now so particularly this particular orientation, that geomagnetic reversal The reversal of the magnetic poles is called as geomagnetic reversal. Okay, so this is the example in front of you, that this is the example that this is the sea floor spreading going on, sea floor spreading. Suppose that these rocks are having some another, so this particular rocks is showing south in this direction, north in this direction. The next sea floor spreading happened, this is showing north, this is showing south, again this is showing south, this is showing north. This is called our geomagnetic reversal. Earlier these evidence, because earlier our ancestors could not go to the depth of the oceans and check these things out. That's why our Alfred Wegener theory was not acceptable till the late. After some time, when we got to know about the technology, we got to know that yes, sea floor is also it also happens, it also present. So what is normal polarity? I'm winding up the lesson that magnetic north points toward the geographic north pole. Whatever is right now, whatever the north pole is, south pole is, that is called normal polarity. And what is reverse polarity? Suppose that in future our north pole has become south and south pole has become north, that will be called reversed polarity. Okay, so these are the common magnetic minerals in geology: magnetite, hematite, pyroxite, ilmenite and geotite. These are the chemical formulas, these are the types, and these are the uses. Okay, so I hope you did understand magnetism, geodynamo, and the short concept of paleomagnetism also. In next lecture we will be talking about the paleomagnetism. Okay, remember that thing. Sea floor spreading we will talk about, and we have to talk about the Viksit Bharat 2-day free workshop of the Universal Institution also, that is going to conduct on 25th and 26th of April. In this particular, you will have the chance to contribute to India's growth, and these are the seat distribution. So if you are falling into this category, quickly do the registration. And for more such videos, like, share and subscribe the channel. Stay tuned. See you in the next one.